This is the first of a two-part series on Jug. This first half will focus on Jug from the user's point of view, and the second half we will look at the internals and at all of the magic that happens behind the scenes. So this is a toy problem. Actually, it's linked to a longer Python tutorial. The links are below, and so you can peruse at your leisure. So let's just look at what we have. So we have a file called jugfile.py. That's a Python file, nothing special there. We'll look into that in a second. And then we have a directory called data with two subdirectories and a lot of JPEG files in those subdirectories. So you can export the data more at your leisure, but here I'm just going to show you some examples, or one example here on the right from this nuclear class, where you can see you have here these cell nuclei. They're roundish oblong filled objects, and on the left you can see the other class where it's actually, you see the images of the cells with the nucleus actually being empty, so, or not marked. And so here the computational task is, can we build a simple machine learning model that can distinguish between these two types of images? And we're going to be using very traditional machine learning. When I've already written the code here, where, so first we do some imports, and then for each image, we're going to compute some features here using this compute features function. And then when we have all of the features and all of the labels, we use this other function called doLearning that learns a random forest classifier from scikit-learn, and finally just outputs the results of the out-of-band score. So this is all very classical machine learning. We're not doing any fancy neural networks here. And then here's a bit of code that drives the whole process. So we start with just get all of the file names and loop over them, compute features, and call the learning function. Okay, so in this case, this is actually runs very fast. So we could just run this linear code with not more than 10-20 seconds, and we'd get our results. But I'm going to show you how we would turn this into a Jug script. So the first thing is we do some imports, and these functions we add these decorators, and so that now they're not normal functions, but they are task generators. And actually that's it. Let's save, go back to the console, and now instead of using Python Jug file as before, which now actually does absolutely nothing, we need to do Jug and give it a command. So let's actually just start with Jug status, and it will tell us that, so it has 104 compute feature tasks to execute, and that's the number of images we have. These are ready to execute, and then it has one do learning task, which is still waiting. And the reason it's waiting is because it needs the results of the features to be able to do the learning. And we can do this. And actually, the only special thing about calling the file Jug file is that we don't need to specify it here. So if we do Jug status, here we have the same thing. And we can do Jug execute to start running tasks. And the nice thing is we can even do a couple of processes at the same time, as many CPUs as you have. And in this case, finishes in a few seconds. And as you can see, one process finished, it ran 28 compute features, and the other processes ran 8, 49, 19. We've called status again. Now everything's complete. And if we look we have here our results file is there, and there it is, just 83.6% accuracy. Not bad for a very simplistic model. So that's it. In the next video, we will look a little bit under the hood and we will try to figure out what's happening and what else can be done with Chug. Thank you.